So here's something that surprised me. A teepee's not a cone. The poles at the back get pulled in tight, the front gets stretched out about 2.5 feet, so the whole lodge leans, and it sits on a floor that's more of an egg than a circle, and all of that's on purpose. Back in 1970, Mother Earth News printed 6 numbers, 6 lengths of canvas for the cover of a Sioux Tipi, and they never said where those numbers came from. They just printed them. So I built this lodge, full scale, in Rhino, with Claude Code doing the driving. And somewhere in the middle of all that, these 6 numbers gave up their secret. Now I'm going to show you the teepee, and it's beautiful, but what I really want to walk you through is how the work actually went. What I typed, what Claude asked me back, how we made a plan together, and how we caught the stuff that went wrong. Because that's the part you can take into your own work tomorrow. So 2 things before we get into the build. First, a teepee is someone's home, and it's also a church. At least that's how the sources describe it. So I'll take that seriously. Now, about those sources. Before we did any geometry at all, we went out and scraped the web for teepee documentation. And what I was looking for was real dimensions and real descriptions clear enough to actually build from. And let me tell you, most of what's out there has neither. But 2 sources did deliver. There was Laubin's book from 1977, which is the standard work on the teepee. And then there's the 1970 Mother Earth News article that prints his pattern with every measurement on it. Complete and accurate, and that's what gave me a Claude to Rhino build the best shot. And I want to be straight with you about them. Neither one was written by the people who actually lived in these lodges, so take this for what it is. It's an engineering study of a published pattern. I'm not claiming to speak for anybody. One more thing, and this matters. Every dimension in this build is tagged in the code. Either it came from a source, and the tag names the source, or I derived it and the tag says derived. So every time it runs, it tells me which numbers are borrowed and which ones are mine. The numbers have receipts, and that I think is important as well. Okay, now the rig. Claude Code talks to Rhino through 31 tools via the MCP. And before I trusted it with a real job, I wanted to test it out with some very simple stuff. I did what I'd do with any new guy in the shop. I tested it. I gave it 4 prompts, each one a little harder than the last. The first one was just, what's in my Rhino document? That's read only. That proves the round trip works, that there's a communication between MCP and Claude Code, or Rhino and Claude Code. The second one, delete the circle and make the sphere radius 8. Simple. So now it's actually editing my model and reading it back to verify. The third one, show me a shaded perspective view. And that one found a bug. I asked it for a screenshot, and instead of a picture, I got back 100 kilobytes of text. Just garbage in the transcript. And the fourth one, open Grasshopper and array a box 5 times. Simple again. Grasshopper is, as you probably know, is Rhino's visual programming environment, and that one prompt exercises 11 separate tools to complete that. So all 4 tests pass, and along the way, 3 things turned out to be broken. That screenshot bug, the connection into Rhino, which died on me twice while Rhino itself just sat there running fine, and the port. If you don't tell it which port to use, it hunts around, grabs the wrong one, and gives up. And that, right there, is the lesson. You want to find all of that out on a toy box in some simple geometry in a test environment in a sphere, not on the job. So start simple and build your way up after you've got confidence, and then apply it to the actual job. So now the build, and here's the thing. I didn't start by asking for a teepee in Claude Code. I started with a plan. Claude Code has a planning mode, as you know. You type /plan and it works the whole job out on virtual paper before it touches anything. And my prompt is up on the screen right now, word for word, so let me just walk you through what it does. I asked for a detailed set of Rhino modeling instructions for a full-scale teepee, true to the plain style. I told it the goal, which was that Claude generates the whole thing from the research, and I should barely have to touch Rhino or Claude at all. And then the part that matters most, I told it, check the work, build a superior plan, pressure test it. So 3 moves in that prompt. You say the outcome, you say how involved you want to be, and you make it attack its own plan before you sign off on it. And here's what a good planning session actually looks like. It didn't start building, it stopped, asked me questions, 4 of them, and every single one changed the job. First question, which was, which tradition? 3-pole Sioux or 4-pole like the Crow and the Blackfeet? I picked Sioux because it's the only tradition with a fully dimensioned published pattern. Anything else, I'd be making the numbers up. Second, what do you want delivered? And I said everything. The 3D model, the flat cut pattern, the bill of materials, the liner, the pegs, the door, the whole package. Third, what units? Inches down to 100th, because the published pattern is in inches and fractions. And fourth, which era? And I went with canvas after 1870 because the canvas seam layout is documented and a buffalo hide cover would just be a guess. It even flagged the cultural framing. It said, this is a call you need to make, not one I should make for you, and I respect that. And then the pressure test earned its keep. It hit that screenshot bug and planned around it, captured the disk instead. It knew the connection dies, so every stage saves the file, and a dead session never costs me more than 1 stage, and every call names its port, so nothing hunts. Then the whole plan came back to me for approval before one piece of geometry ever existed. I read it, I pushed on it, I corrected a few things, and then I said go. So the build runs in 10 stages: foundation, poles, cover, all the way through the door. And you can run any stage twice and get the same lodge, not 2 copies of it. Every stage prints what it measured, and every stage has to pass its checks before the next one is allowed to run. And the checks come straight out of the books. The gray band is what the sources allow. The dot is what the geometry actually did. If the dot doesn't land on the gray, the build halts right there. Every pole has to come in between 22 and 25 feet. The back wall has to be steeper than the front. Miss one, and everything stops. Now here's why those gates matter so much. My solver had a setting for how far the top of the lodge leans back, and it came back 0. Not because 0 was the right answer, but because of the way I'd written it. Every answer that worked scored exactly the same, so it just handed me the first one it found. The setting I put in to control the lean was doing nothing at all, basically, and every check still passed. And that's the thing you've got to understand about these tools. They don't break. They do exactly what you told them to do, and sometimes what you told them to do was wrong. The checks are how you catch it. The checks are how you catch yourself. Now I steered this build twice in the middle of it, and both times 2 sentences of typing changed the outcome. That's something important to note. The first time I said, full honesty, show the failures in a minute. The second time we needed some captures, and Claude was about to rebuild the whole model from scratch. And I stopped and said, well, that's kind of dumb. And I just asked, why rebuild? We saved the file, load it. So it loaded it way faster, and loading it flushed out 2 more bugs on the spot. Opening a file over the connection can crash, and when it doesn't crash, your stage checkpoints don't come along for the ride. You have to carry those across yourself. That's the job right there. You're not typing much, but you're steering. Remember to use your judgment, your domain knowledge, and human in the loop is important. Okay, now the part that nobody planned. Stay with me a little on the geometry here. The floor of this lodge is not a circle. It's 20 feet front to back and 17 and a half across. It's basically an egg shape. The back poles sit closer to the middle, which makes the back wall steeper. And the steep side is the side you point at the weather or into the wind. But here's the conflict. The cover gets cut as a half circle. At least that's what the pattern shows at first. 1 radius, 19 foot 3, swung from a single point. And a half circle will only sit properly on a base that's round, not egg-shaped. So if you try to force it and make every pole the same length, then the lean disappears. So you can have a cover that fits or a lodge that leans. You can't really have both. And the 1970 article admits this right there in the text. Their fix was to sew in 2 extra wedges of canvas about 3 feet wide, 1 on each side. Those wedges are the slack, essentially, in the system. All right, the 6 numbers that I talked about from the beginning. Here they are: 38 foot 6, 38, 36 7, 34 4, and 30 foot 10, 25 10. These numbers were printed in 1970, but without explanation. Now watch what happens when you swing that 19 foot 3 radius. Every one of those lengths is exactly how wide the half circle is at the height where that strip of canvas sits. Strips 1 and 3 land dead on. Strip 2 is 4/10 of an inch out, basically within tolerance. That's a pattern maker doing arithmetic. And it sat in a magazine for 56 years and nobody ever wrote it down. But in doing this exercise, my checks found it. I wasn't even looking for it. That's, in a sense, part of the brilliance of using AI as your co-partner in building stuff like this. And then it kept happening. The pole set came out at 328 pounds, and the encyclopedia says around 400. The cover came out at 62 square yards, and they say 68. My 7-inch pin spacing gave me 13 lacing pins, and the magazine says 11 to 14. And here's the thing. None of these were targets. I didn't put that in the plan. Nobody was aiming at them. They just fell out of the geometry. And when numbers you never aimed for keep landing inside the published ranges, that's when a model starts earning your trust. Now let's talk about the failures. And there are 2 kinds. The poles came out poking the canvas like ribs. At first, the smoke flaps looked like a chimney 3 tries in a row, and I caught both of those just by looking at the screen. But here's the one that matters. One stage told me door panel and frame built, and only the frame was there. The panel had failed quietly, the function came back empty, didn't complain, and the stage said done. Obviously it wasn't done, I could see it on the screen, and listen, nothing in that report was a lie, it just wasn't true. And there's one more, and this one you can't catch by just looking. The top edge of the cover tapers and then goes flat. I'd drawn that taper as a straight line, so where it meets the flat, there's a corner. 2 of the 16 panels sat right on that corner, and it broke them. You cut those 2 out of real canvas, and they will not lie flat, and the error was 0.6%. The good panels came in at 4 ten-thousandths. Every render looked perfect. The only way I found it was to flatten all 16 panels and compare the areas. I rounded that corner off and I got 20 times better. And what's left over, where the cover doesn't quite fit, comes to 4.5 inches. So your eyes catch one kind of wrong, measuring catches the other, and you need both. You really do need both. So what carries over to your work? Well, 2 things have to be true before you try this. There has to be a written source that pins your numbers down, and the geometry has to be able to check itself. If you've only got one of these, don't bother. Where does it work? Well, historic buildings where you've got published drawings, anything driven by code, so like stairs, handrails, exit widths, and any flat pattern work, because a flat pattern either unrolls or it doesn't. This is partly why I chose the TP. And where it doesn't work, well, free-form surfacing, the model can't tell you a surface can tell you a surface closes, but it can't tell you if it's any good. And anything where the call comes down to taste, that is not going to happen. So here's the method, and you can write this down. Test your rig on toy geometry with prompts that get harder as you go. So plan before you build, and make the plan, take your questions, and attack itself. Tag every number with where it came from, write your checks before your geometry, not after, and make every stage say out loud what it did and did not do in the build. The model did the geometry, all of it, but whether you trust it, that part is still yours.